Hi, everyone. So welcome to our talk, the next level of telco observability for autonomous networks using OpenTelemetry. I'm Faseela. I'm a cloud-native developer at Ericsson, also the technical oversight committee member at the CNCF, and a CNCF ambassador too. And you will see me in the upcoming 3 days as the KubeCon co-chair. This study is, as I always say, it's Jörg's research and study. I'm here only as a CNCF GOC member to support him with open source side of things. And then, I usually use this as a perfect opportunity to shed some light over the overall observability landscape in the CNCF. So over to you, Jörg, for intro.
Thanks a lot, Faseela. My name is Jörg Aelken. I'm also working for Ericsson as an expert for cloud-native telco management systems. What we would like to share with you today is a bit a telco flavor here. So, of course, our systems are rather complex. They are heavily regulated, but nevertheless, we are also depending a lot on open source solutions, especially for the observability of our applications and systems. So just to give you a hint about what specific characteristics and capabilities our applications do have, and then I will also go into a little bit on management architecture for our network functions, and touch a little bit upon data requirements, which are enabler for autonomous networks and their management. So I will come back to that one. And then, as Faseela said, she will also then further on connect it to the CNCF ecosystem and the observability landscape. So a bit around telco applications for those of you who are not so familiar with those ones. These telco applications are, when they are designed upon cloud-native design patterns and principles, they consist out of many microservices themselves. So they're rather complex applications. And also they are usually very heavily disaggregated and deployed on multiple cloud stacks. So it's not just a few microservices or a few pods. There are really hundreds and thousands of them, which make up such an application. That is also maybe a little bit specific for telco, is that we differentiate between a functional versus a realization view. So what you might mainly be familiar with is what we call the realization view. So that's the pure software instances running on the cloud stack where you're managing individual systems and so on. But also from the management systems point of view, we have so-called network functions, which are specified in standardization. They are supposed to fulfill certain capabilities and provide them to the mainly telecom networks. And they also have what we call kind of more a logical function. So they're aggregated and exposing their capabilities and functions towards the management systems, but also over certain APIs to the overall telecommunication network. And what we talk mainly about here is the resource view. And also for these resources, we apply certain orchestration. Maybe here in this forum, you're much more used to it, like we are using also Kubernetes to mainly orchestrate on this lower level, on the resource levels, but we also have higher levels. So, due to these kind of nature of our applications deployed on the cloud stack, we have certain challenges, especially for observability of our applications. One of them, I touched upon it a bit, is this what we call layer software architecture. So we have lower layers like on infrastructure, and then we have platforms, but we also have, as I explained before, the logical layers, and then we have service layers and so on. This is also a bit connected to the architecture for autonomous networks. I can come to that in a few minutes. Then I already mentioned those applications are heavily distributed and disaggregated. And also maybe a little bit specific for telco applications is the multi-networking. We cannot only rely upon the native cluster and networking, but we also usually use secondary networking so that we have all the interfaces which are required for our telco applications available. And of course, we would like to monitor and observe them as well. A little bit not really specific for telco applications, but still we are maintaining the logical function all the time, even though the resources are ephemeral. You might be used to that. I mean, we've got restarting pods and so on. They have got changing IDs, so the actual resources are ephemeral, while we would like to maintain our logical function to be stable. And this is also a certain challenge for us when it comes to monitoring and observing them. Something which is also, I think, more specific for telco applications is that the resources we are having, they are shared between applications. So we have certain functions and services which are made up. They are used by multiple applications. So it's also a little bit more of a correlation challenge in order to point to the individual functions when it comes to monitoring and observability. And also, which is, at least in the telco world, quite a paradigm shift, is the change towards continuous data streaming. So from the, let's say, more traditional way of monitoring telco applications, this is more bulk-based. You might be used to ROB files which are reporting output periods. So usually the applications, they themselves generated and collected their data, and then they were kind of exposing them every 15 minutes or so with their monitoring data, which of course is in modern, let's say, observability systems. That's not desirable because it's much too late. So we would like to have near real-time data streaming in order to analyze and react upon those data. So these are telco challenges for the observability. And now I'm going a little bit into a more detailed architecture for managing those ones. What you see here is the, let's say, blueprint for autonomous networks. Autonomous networks is a big thing in the telco industry at the moment. Everyone is talking about that. If you see that all the kind of communication service providers, the CSPs, everyone is talking about they would like to achieve autonomous networks, autonomy level 4 within the next years and so on. But it's of course a big question how we are going to achieve that. On the left-hand side, that is the very simplified blueprint, which is specified by a standardization defined organization, the TM Forum. They are talking about different layers, and they are specifying from top down the business layer, which is concerning management of business systems, the contracts, the users, and stuff like this, very simplified. Then we have a service layer, which can be divided into an overspanning end-to-end service platform, and the individual domain services. We usually divide into the main domains into the radio access network, the RAN, which is basically the radio systems, the antennas and their corresponding applications. Then we have transport, and we have got the so-called core service, which are the more logical functions in the mobile networks specifically. And then on the resource layer, we have these individual domains, which I've explained right now. And also in this domain, you find what we call a network function. These are the real specified telecommunication functions which are applied. And for all of that one, for all of these layers, it's important to understand that we need very concise and aligned data management for the observability. It's one of the biggest enablers for a so-called closed loop automation. So if you would like to automate as much as possible in order to manage your applications and systems, then let's say from bottom up, you will need from all these different sources the data. The data is used, for example, to compare towards a wanted state of your application. This is what we also call in that area a kind of intent-based management. So the upper layers or the user specify a certain intent. You can see it as a type of declarative way to describe how your system or your function, your application is supposed to behave. And of course, in order to evaluate if this wanted state is reached, you also need then near real-time management and observability data in order to check actually if your wanted state is reached or not. And from that one, in a more or less automated way, we can then also decide upon certain mitigations in case your current state is not reached. So these are very much, how shall I say? Yeah, they're technology enablers. And the cloud-native observability is one of the keys there for closed-loop automation, which in turn helps then us as a vendor, but also the network providers, the owner of these networks to achieve higher level of autonomy in their management. Very quickly, we identified then when we were thinking about more specific an architecture for cloud-native telco observability. We identified main capabilities, main functions in order to handle those ones. So of course we have a data source, we have some forwarding capabilities, we have processing of this data, and of course a certain exposure towards any type of external consumers. What we have specified then is what we call then, as I said, the observability functional architecture. It's very logical, it's very high level. You can drill down and double click on each of these components there in this architecture in order to further investigate how they are designed and also how they can be implemented. Most important parts here is from bottom up, we have the data sources combined here as platform and infrastructure data sources. And on the other hand, we have the application layer where we have then the applications also on their context and their domain exposing their data. And then we have an externalized observability data management layer. And the important thing here is also compared to traditional ways of building telco applications, when it comes to observability, we have the paradigm here now that we expose and export and transport the telemetry data as it is rather soon from the applications and the different data sources. In the past, we had applications who are basically physical network functions. They're appliances which own everything from the infrastructure, from the server, the operating system, everything up to the application layer. That is not the case any longer. So therefore, we need an external system which is able then to aggregate and correlate that data in order to create certain views. So this is one of the most important things which I can emphasize here. And this is also, especially when it comes to telco applications, a big paradigm shift, which is also now represented in standardization. For those of you who are a little bit familiar with telco standardization, in this architecture, you can see that, for example, the lower layer is represented in the standards specified by the O-RAN Alliance that would comply to the O-Cloud, which is specified there. The applications, they are specified both depending on which type of applications you have, either in the O-RAN Alliance or in the 3GPP standardization. And then, of course, the upper layers, these are the management systems. Lately, we have, for example, a so-called SMO, which is also specified in the O-RAN Alliance, which will fit to those kind of capabilities in the management stack. And for those of you who are interested in interfaces, so we are also applying these type of information to corresponding interfaces, which are specified, for example, here in the O-RAN Alliance. So from the O-Cloud, the platform infrastructure, there's a corresponding O2 interface. There are actually two interfaces, and from the applications, we have, for example, the O1 interface. So much about standardization, data requirements. For the sake of time, just the most important ones we have identified. Most important, most of you will already know that from the observability community, data must be structured. So In the past, we had a lot of unstructured data, which is a headache when it comes to correlating, aggregating the data. So it's really essential that all the data is structured. And secondary, the data must be traceable to its source. So we need source IDs so that we have consistent information about where the data comes from. The other ones, they're also interesting, but of course, we would like to give it also CNCF flavor, and by this, I hand over to Faseela.
Thank you. So yes, we have learned about the telco observability part, and then some challenges, and also, more details about the design principles as well. So now let's take a look at how all of these things or some of these challenges are solved by some of the CNCF projects out there. So yeah, on the sake of time, let's move faster. So when we talk about observability in telco, open source is actually the key driving factor for innovation. Actually, that is a combination of various things, starting from open standards, as what Jörg already mentioned, to closed loop telemetry and automation. So when I talk about open standards, things like OpenTelemetry, 3GPP, and ETSI frameworks, all of these things are making sure that the data flows across layers without vendor lock-in. And then I have mentioned a few projects, open source projects here, but it's not the full landscape. As you know, the landscape is really broad and fast evolving as well. So maybe let's take a quick look at how some of these things are coming together in the 5G cloud native environments. The projects like OpenTelemetry provides us unified telemetry collection, and then for example, Prometheus and Persis are projects which handle metrics and visualization. We have Jaeger providing distributed tracing, and if you think about the ONAP project and under the Linux Foundation, it extends all of these things into closed loop automation. As a person who has worked on some of these projects, what is the key value that this is bringing in as the interoperability? All of these projects try to speak the same language, which is very important for end-to-end network visibility. So yes, this is the overall CNCF observability landscape. As I know, this is the observability day, and then that too at KubeCon, I don't think I have to talk in detail about this. But one thing I wanted to highlight here is the flexibility that this vast landscape is bringing in, the flexibility to mix and match or discover and also frame your own observability stack based on your specific requirements. So that is the flexibility this landscape is bringing in for you. And this is very crucial for telco autonomous operations as well. So now let's take a simple example of a telco-specific problem and then discuss how the CNCF projects are helping to solve that challenge. It's not a big thing, but yeah, whoever is working on telco can easily relate to this. So we have just picked one example. So one of the challenges we often face in telco cloud environments is traceability, especially when the network address translation is into play. So in traditional networks, we could depend on static VIPs to solve this problem. But in Kubernetes and KaaS environments, the addresses are dynamically changing, and so it's very difficult to maintain this traceability just as is. So from my experience working on the Istio project, we have seen this problem in many of the large-scale deployments. So the key is to design observability in such a way that the trace context can span across these translations. So this is where the CNCF stack really shines with OpenTelemetry. We can instrument components to emit traces even across these snatch boundaries. And if you envision this, it's like eBPF can provide kernel-level observability and visibility, and platform logs and CNI extension logs can fill in the gaps. So the data can then be correlated using trace IDs, metadata, and attributes that will give you an end-to-end picture of what's happening across the stack. So this is something that the community is actively working on. And if you see, there are multiple projects involved here. And when all of these projects are working together in a collaborative fashion, you can see how fast some of these innovative solutions are evolving. OpenTelemetry plays a crucial role here. It has this context propagation that keeps the trace context intact across the hop, so that even after address translation or redirection, we can maintain the visibility. And OpenTelemetry also has this custom instrumentation, which allows you to inject NAT-specific details into the trace. Like you can inject table lookups or connection IDs into the trace span, so that also helps in such cases. So this is like a simple example, but a great example that shows how the open source collaboration is solving a telco-specific problem. And before I dive into the collaboration opportunities, I want to just reiterate how important OpenTelemetry is for telcos. It's more like a game changer for telcos, giving us a scalable and flexible and standardized way of collecting traces and logs and metrics. And we do see opportunities for collaboration in certain areas in the OpenTelemetry, especially for enabling safe upgrades, fine-grained collector configuration, and expanding the semantic conventions to support telco-specific protocols and alarms. So we can all work together to make OpenTelemetry even more powerful and telco-friendly. And I have this final slide that really captures the direction we are heading in. So basically, I have tried to capture where the open source ecosystem, including the Linux Foundation and the Cloud Native Computing Foundation projects, are coming together to build it's like the whole set of projects building the backbone of future autonomous networks. So from the Linux Foundation, you can see Silva, CNTI, and ONAP, enabling orchestration, lifecycle management, and automation that can make the closed-loop operations possible. And from the CNCF side, projects like OpenTelemetry, Prometheus, Kubernetes, and Istio enables real-time observability and also make sure that all the policy control layers are in place to feed into those loops. And you can also see how the next wave of technologies are evolving. For example, eBPF-based network-level observability and AI/ML-based analytics using OpenTelemetry data streams, and intent-driven orchestration based on ONAP policy engines. All of these things are transforming us from reactive networks to more proactive and self-optimizing networks. And as a person who is working both on the CNCF side and the telco side, it is more like I see how all of these projects are really driving the future of autonomous networks. It's really important to see how the whole ecosystem and the open collaboration is evolving into like an open and shared data foundation where data, intelligence, and automation is coming together and converging. So together we can make sure that such a future for the autonomous networks is possible. Yeah, that's all I had to cover here. And then maybe if you have any specific questions about telco observability, Jörg is here. Or if you have any questions about the open source side of it or the CNCF projects, maybe you can ask me here or later. Yeah. And yes, don't forget to give feedback for the session.
Thank you.
Thank you.
Any short questions? Otherwise, you can also meet me or Faseela afterwards. Getting hungry? I think it's lunch break now, as far as I know. So, thank you very much. Have a nice day. Enjoy the KubeCon. Thank you.